There's one remaining exponent rule that we need to take a look at. Going back to our division rule, our quotient rule, a to the n divided by a to the m, we know that we're going to subtract the denominator's exponent from the numerator's exponent and get a to the n minus m. We can work out an example like we've seen before in part b. 6 to the 7th divided by 6 to the 4th, well, 7 minus 4 is 3. But one of the things that can sometimes happen is that the denominator's power is greater than the numerator. So in parts C and D, you'll notice it's the same example, but we're going to approach it two different ways. On the one hand, in part C, we'll approach this for what it means. 3 squared over 3 to the 6th means I have 2 3's in the numerator and 6 3's down in the denominator. When we cancel these 1 for 1, we see that the 2 in the top cancel, with 2 of them in the bottom, but there are still 3's left in the denominator. In fact, because 2 of the 6 canceled, we still have 4 3's down in the denominator. But up in the numerator, we have 1 times 1. So 3 squared divided by 3 to the 6th becomes 1 over 3 to the 4th. But if we approach this using our quotient rule that we had in part A, where we subtract the bottom exponent from the numerator exponent, we'd end up with 3 to the 2 minus 6. Well, 3 to the 2 minus 6 is negative 4. And one of the things we will come across is negative exponents. So the final exponent rule is to develop an understanding of what a negative exponent means. Since we approached C and D, which was the same expression but from two different perspectives, and we get two slightly different looking answers, the two answers have to be equivalent, meaning 1 over 3 to the 4th has to be the same thing as 3 to the negative 4. A negative exponent simply means you are dealing with the reciprocal of your base, and we'll look at a few more examples to become more comfortable with this idea. In part E, we have 7 to the negative 2nd. The negative tells us one thing, while the 2 tells us something different. The negative on the exponent simply means we have the reciprocal. We have 1 over something. 7 to the negative 2 means we have 1 over 7 squared. A negative exponent will only ever mean reciprocal. In part F, we have 2x to the negative 6. One thing is we have to remember the negative exponent will mean we're dealing with the reciprocal, but still exponents only apply to what they are touching, what they are immediately next to. So 2x to the negative 6 means we are dealing with x to the 6th in the denominator. That's the reciprocal component. But the negative 6 has nothing to do with the 2, so the 2 will remain in the numerator. So 2x to the negative 6 means 2 over x to the 6th. A negative exponent means reciprocal. So our general rule, a to the negative n, means 1 over a to the n. And again, because we are dealing with this a ending up in the denominator, we do want to point out we're not going to ever work with this if a is 0. So then the question becomes, what if you have a negative exponent in the denominator? Well, it means the same thing. It means reciprocal. What is the reciprocal of 1 over something? It's that something over 1. 1 over a to the negative n is a to the n over 1. That's the reciprocal. But since we don't need to ever write a denominator of 1, we would simplify this down to just a to the n. A negative exponent only means reciprocal, and another way to think of reciprocal is it belongs on the other side of the fraction bar. In part E, we really started with 7 to the negative 2 over 1, and so that negative meant throw the 7 squared in the denominator. In part F, we really started out with 2x to the negative 6 over 1, and that negative 6 meant the x to the 6 belongs in the denominator. Negative exponents mean reciprocal. So a negative exponent in the numerator means throw it down to the denominator, and on H, a negative exponent in the denominator means throw it up into the numerator.